Okay, so today is one of those days where you just gotta give me undivided attention so you can get this stuff, and then once you get it, you'll go do it, and it won't be a big deal. So I want to see earbuds, phones, all that stuff has to be completely away. Got a little time for that now. Awesome, thank you. Okay, that's fine. Okay, so today we're gonna look at we're gonna look at something called completing the square. And that's kind of, if you had to break this down to, what's the topic of the day, it's completing the square, but let me describe that to you. So we're gonna start off by this seems like a strange question, but which of these two would you rather do? The right one, for sure. How come? It's easy, yeah. There's a single x there, so we're gonna, in the case of the right quadratic equation, this is the easy kind, right? There's a single x that I can point to, and if I can point to a single x, I can isolate it by just reversing PEMDAS. In fact, that's easy, there's only 2 steps. What are they? Square root both sides, and then add -2 to both sides, or subtract 2 from both sides. Easy, 2 simple steps and we're done. So if we go through those steps, just to remind you how simple that is, if I square root both sides, I'm just going to get x plus 2 equals plus or minus square root of 3, right? And then last step is just add -2 to both sides, and so in 2 easy steps, I get both my answers, -2 plus or minus square root of 3. Piece of cake, right? This guy over here, I mean, what could you do? You could try to find magic numbers. Do they exist? No, they don't. So we'd have to go on to a new technique that we don't even have yet, right? To solve this thing, we have to plug this stuff into the quadratic formula, which we haven't even learned about yet. That's coming up, right? But even the quadratic formula, and it's not like it's terribly difficult, but there's a lot of computation. This is much easier, right? If we can get it to work that easily, it'd be nice to do. Okay, so let's just take a look. There's a weird trick that we can do to move from, in fact, this equation right here actually turns into this very simple equation if you do this little trick that I'm going to show you today. Okay? So where's the trick come from? Well, it comes from a picture. It comes from this picture. So here's where we're starting with our picture. We're just going to add up an area, right? So we've got the area of a square plus the area of a rectangle. Now look at the dimensions of these things. Well, the square has dimensions x height by x width. So the area of the square is just x squared, right? This rectangle, obviously it has a height of x, right? Same height as the square, but it's got a width of b, and so we know how to calculate area of a rectangle. It's just width times height, or length times width, or whatever you want to call it. So it's just b times x, right? So bx. Okay, so what we're going to do with this, though, is we're going to divide this up into a way where we're going to try to build a square out of it, build a single square. Any suggestions how we could, we're not going to get all the way to a square, but how could we maybe cut this guy up and place it strategically so it can start to look more like a square? Any ideas? Kind of think in terms of, what if these were pieces of cardboard?
You can put it in the square.
Go ahead, Alice, what do you got? Thank you.
You can cut bx in half, or vertically, right?
Okay,
Put one half inside, the other half.
perfect, right? We could cut the rectangle in half. Thanks. Cut the rectangle in half, and let's split it up, right? We'll cut it right down the middle, and we'll take one of those and shove it up against the side, and one of those we'll flip sideways and put it up against the bottom. So it looks kind of like that, right? We'll place those. Now that's close, right? It's close. We haven't changed the area, have we? Total area stays the same. It's still x squared plus bx. If we wanted to turn this into a square, we're missing one little gap in the corner, aren't we? Right? We're missing that one little gap down there. Well, what are the dimensions of that extra little tiny square we'd need to add to turn this into one big square? Instead of 2 areas, just one big simple area. What would the width of, what are the dimensions of that little piece that's going to have to fit right down in the corner? Not b squared. B, 1/2 of b. right? Because we're cutting this width in half, aren't we? So now it's just b over 2. Right, would you agree that this little square that's going to go in the corner down here, and let's draw it, this little square that's going to go in the corner, it's going to have a width of b over 2 and a height of b over 2, right? So isn't its area just going to be b over 2, whatever that number is, squared? Would you agree? Okay. So who cares? What's the point, Mr. Wright? Why are we doing this weird thing? Okay, well, so if we just add this one little piece down there, we're completing the square, and we're going to be able to write our original area, x squared plus bx. If we add one little extra bit to that, we can write it as the area of a single square. Now, what would the area of this square become if we put that little green extra piece in there? The dimensions are just x plus b over 2, right? How do you calculate the area of a square? What do you do? Multiply what? Width times the height, or width times the length, whatever you want to call it, right? And so I'm just going to multiply x plus b over 2. That's our new height. And x plus b over 2 is our new width, right? If we include that little piece. And wouldn't that just become instead? It would just become x plus b over 2 squared, right? That's easy. We just write it as one perfect square. Instead of having to write it as a sum, we started off having to write the area in 2 pieces, right? Okay, so that's, believe it or not, that's our strategy. That's what we're going to do to this problem that we just looked at. We're going to follow those same steps. It's not going to be geometrically, right, but it's going to represent the same process. Okay, to summarize that, let's see if we can see what we did. We started off with the area x squared plus bx, and we reconfigured the area so it almost made a square. And then we added this one little additional piece that had an area of b over 2 squared. And what did we get? Well, we ended up getting one big square with the area x plus b over 2 times itself, or x plus b over 2 squared, right? And so what can we say about that? Well, our original area plus that little extra area that we added to complete the square, to fill in the one little blank, one little gap at the bottom right, ended up equaling x plus b over 2 squared. That's called completing the square. Why is that valuable to us in terms of algebra, right? Well, look what we started off with. We started off with an algebraic expression that had multiple x's in it, right? We can't isolate x. We ended up with an answer that only has a single x in it. That's useful, because if it only occurs once, we can just isolate it by reversing PEMDAS, right? So let's try this process, okay? So in order to do this, here's kind of our recipe. So we'll start off with this equation, same one that we started off with on page 1, and we're going to do the process of completing the square so we can solve this by isolating x. Okay, so what's step 1? Well, step 1, if you look back, we had to get our original expression in the form x squared plus b times x, right? So we want just x squared plus some number times x, and that's it. If we start with those two terms, we're going to be able to add just the right amount to turn it into a perfect square, to complete the square, okay? So in our problem, step 1, we always want to get it into the form x squared plus b times x, and we'll leave a space for another number, equals some number. Okay? How do I do that to this equation? Subtract 1, right? That's it. If I just subtract 1 from both sides, now I get to my starting line, right? I get to the point where I've got x squared plus 4x on the left side equals -1 on the right. Okay? So think what we're going to do here now. We're going to add some number to that side of the equation so that this becomes a perfect square trinomial, something that's going to break apart into a perfect square. So it's going to end up equaling x plus some number quantity squared. Right? It's going to look like only a single x appearing. Okay, but we got to think about this. If I'm going to add a number to the left side to make this stuff happen on the left side, this is an equation. So what else do I probably have to do? You got to add it to the right side too. right? So I'm gonna add that same number there, and then the left side is gonna be a piece of cake. I'm gonna get x plus some number in parentheses squared. All I really need to know on the right side is what number is that equal to, right? Like, for example, in our first problem, it was equal to 3, right? I got x plus some number squared equals 3, and it was super easy to solve by isolating x, right? We did a bunch of those at the start of Unit 2. The first assignments were about that, right? Oops. So how are we going to determine what number goes there? Well, here's the order I think you should use, right? We always know that if I start off with x squared plus bx, so that's my b is 4, right? We always know that the perfect square we're going to build is going to be of the form x plus b over 2 squared every time, right? Has to be. Look back at our picture. That's what we got, right? X squared plus bx plus some extra number gave us x plus b over 2 squared. So the first thing we do, the very first thing we do is we'd write out this whole template before we fill in any blanks. And the first thing we would do is figure out, well, what's the number that goes there? If b is 4, what number has to go there? 2, half of b, that's it. Whatever that number is, we're just going to divide it by 2, so we get 2. So we already know that on the left side of the equation, we're going to get an x plus 2 squared all by itself. The only issue remaining is we got to know what number goes on the right side, so we can isolate x. Okay? So step 2, make that a little better. So that's the number that we're cutting in half, right? And we get 2. Next step, whatever that is, that's b over 2, right? The next step is we're going to square it, because the little extra piece of area we had to add was just b over 2 squared. So whatever that number is, we're just going to square it. Got to add it to both sides. Well, what is 2 squared? 4. Right? So step 2 includes adding it to both sides of the equation. And then finally, step 3 is we're just going to determine, well, what's that leave us on the right side? If I add all that stuff up, what do I get? What's negative 1 plus 4? 3. That's completing the square. Now it's easy. Now we just isolate x. Right? Okay, let's try that again. Let's just practice that process, because there's really only, how many steps are there? Well, I guess there's one step just to get it into the starting form, x squared plus bx on the left, the number on the right. So there's one step. But then these other 2 steps just go together, right? So let's try this again. Let's try, I'm going to skip up here to that guy. Okay? So we're starting off with x squared plus 8x minus 2 equals 0. So what do we got to do first? Okay, we got to add 2. Good. So the first step is step 1. We got to get it into the form x squared plus bx equals a number. So we're going to add 2 to both sides, and that gives us x squared plus 8x, leave space, equals 2. Okay? Before we do anything else, let's write out our template so we know we're going to get that stuff. We just have to fill in the blanks. Right? Before we do anything else, we know on the right side or the left side, we're going to get x plus some number squared equals something on the right side, and that'll be our answer. We'll have the square completed at that point, and then the problem's easy to solve. What do we do first? Divide 8 by 2. Good. So step number 1. This is b, so we need to get b over 2 is going to go right there, right? So we got to divide 8 by 2 and get 4. So there's step 1. Right? So we know we're going to get x plus 4 squared equals some number. the two steps to solve this are gonna be easy eventually. We're just gonna square root both sides and add -4 and we'll be done, right? Just gotta know what number goes there. Okay, so, Savari, what's next? That was step 1. We found what b over 2 is. Now what? Good. So we're gonna add whatever that is squared to both sides, right? Well, what's 4 squared?
16.
So everybody agree we added the same thing to both sides? We treated both sides equally. Good. Do we really even care that that's what's up here? Not really. But we need to know what number we get on the right side, right? So what do you think? What's next? Dan, or what's the last step? Well, we're just, at this point, we've already got everything on the left side. We just gotta know what, yeah, what is that? 18. Good, so that's our last step. Last step is we're just gonna add up all the numbers on the right side, and we get 18, and that's easy, right? Then from there on out, solving it is stuff we've already practiced. If we have x plus 4 squared equals 18, you know, what do? First we square root, right? So if we square root both sides, x plus 4 equals what? Plus or minus. And the square root of 18, if we make a factor tree out of 18, what would be a really good way to do that? 9 and 2. Because 9 makes a couple of 3s. So what do we get? 3 radical 2. Good. And then last step? John, what's the last step? -4. Yeah, good. So we'll subtract 4 from both sides, and we get x equals -4 plus or minus 3 radical 2. Boom. Okay? No big deal, right? Let's try another one. What would we do here? Add 3x, good. Add 3x. And while we're at it, what do we probably want to do with that 13? Subtract 13. We want the number on the other side, right? So that's perfect. We get the x's on the left and the numbers on the right, just like we want. We get x squared minus 6x equals -13, right? So what am I going to write next? And I really want you guys to do it this way. Carson, what's going to be next? You don't have to do any thinking here. I'm just going to write down, I'm going to build my template so I can fill in some blanks. Well, what did we do? I wouldn't have to think about anything, but what's the next step going to look like? Parentheses, squared, right? We're going to get a perfect square on the left. That's going to be an x, right? And now I've left blanks for all the stuff I need to fill in. Okay, does that make sense? Every time, just do that. You don't have to think. That's just when you complete the square, you know that's what the next step has to look like. So write it down. Now we can start thinking. Okay. Okay, so good. Next step. Cooper? Divide by 2. So we've got b is equal to -6. So half of -6, -3, right? So that means step 1 is we're going to get a -3 there, right? The previous examples have all been positive, but it can be negative, no big deal. So x minus 3 squared equals, that's what we got to find out. Okay, Ian, what's next then?
I don't know.
Yeah, you do. Come on now.
No. No.
So if this is b over 2.
3x squared, yeah.
So that's b over 2. We have to add b over 2 squared to both sides, right?
Yeah.
So then whatever -3 -3 squared is. What is -3 squared? 9. +9. So we're adding 9 to both sides, right? Everybody see that? Whatever number you get here, this is half of b, you're just going to square it. That's the missing part up here. right? It's the missing piece to complete the square. We've got to add that to the left side and the right side to get this to happen. Everybody see that? By itself, x squared minus 6x is not equal to x minus 3 squared, right? X minus 6 plus 9 is equal to x minus 3 squared. We've got to add that one little extra piece to make this happen, which is what we want to happen, right? So then, Walker, on the right side, what do we end up getting? Negative 4. Good. What would the last two steps be now? Now it's easy. What do we get? Square root. So that gives us x minus 3 equals, what about this side? Plus or minus, good. Now what about if I get a negative inside a radical, what's that mean? I. We get an I in our answer outside of any radicals, right? So we know we're getting an I. What's the square root of 4? So plus or minus 2i. Last step, add 3. Right there. And so we get the answer, x equals 3 plus or minus 2i. Those are my two answers. Right? Okay, let's do one that's just, we got to do one that's a little bit harder. How about this guy? So we have one, there's one little extra part here that we got to do. It's not a big deal. So we got to subtract 10x, good. Because we got to get x squareds and the x's on the left side, right, to start with. Okay, that's good. What else? Add 12. So that gives us 4x squared plus 12x equals what? Positive 7? Everybody agree? Yeah. Well, that's not quite what we need, right? To start this thing off, remember, on the right side, we need to get x squared plus bx equals a number. What's wrong with the picture? There's a 4 in front of the x squared. Well, how do I undo? I got to get the x squared by itself. How do I undo multiplying by 4? Divide by 4, right? I'm going to divide both sides by 4. Because I've got separate terms, it makes it a lot easier if I just divide each term by 4 instead, right? So that works. I get the 4's cancel, so I get x squared. 12 over 4 reduces to 3. And then finally over here I get 7/4. So now we're in the same place we've been, right? This one's a little bit trickier though. You'll see why. Now we'll go ahead and just set up our template, right? We know that we're going to end up adding some number to both sides up there to get a perfect square, right? First thing we do, okay, we're going to divide 3 by 2, aren't we, right? Dividing 3 by 2 gives us, unfortunately, a fraction, right? It doesn't reduce. 3 over 2 doesn't reduce. So if this is b, then we're going to have to add we got to add half of that, which is 3 over 2 to x. Okay, what's next? Ian is your specialty. What you did last time. What do we do here? Square it. Good. Square it. So 3 over 2 squared. Well, what is 3/2 squared? You just square the top and square the bottom, right? What do we get? 9/4. Okay, right? And if we add those up, let's see, what do we get here? We get 7/4 plus 9/4 is 16/4, which is what? Good. And now we completed the square. Now we just square root and add negative 3/2 to both sides. And we're done. Okay, so that's going to give us, it unlocks, right? Unlocks the squared. So x plus 3/2 equals plus or minus 2. Last step. subtract 3 halves. Those are my two answers, and I can get actual answers for this, can't I? Negative 3 halves plus 2 is going to give me just some number. If I take the plus sign, what do I get? What's negative 3 halves plus 2? What would that be? Well, 2 is, if I get a common denominator, how many, I could write 2 as how many halves?
2,
No.
1.
No.
4.
4, right? 2 is just 4 halves. Right? I could just multiply 2 over 1 by 2 over 2 and get 4 halves. So I'm going to get x equals negative 3 halves plus 4 halves is how many halves?
No, 1.
So there's one answer. What if I take the minus? I'd get negative 3 halves minus 4 halves, negative 7 halves. Okay. So on the assignment, here's the kinds of questions you're going to get. You're going to get some questions like these. Very simple. All they're asking you is, what is the additional number I'd have to add in that first step to make that a perfect square trinomial? So what's the recipe? Well, what's b?
Negative.
So what's b halves? b over 2. Negative 3 over 2, so I just square that, right? We always just add b over 2 squared. So in this case, c is just going to be negative 3 over 2 squared, which is what? 9 over 4. It's always going to be a positive number, isn't it? Because we're squaring something to get it. Okay. What about that one? That looks a little weird. But in this case, what's b?
1/3.
So what's b over 2? I don't divide a fraction by 2. Instead, I multiply by what? 1 over 2, right? We multiply by the reciprocal. Instead of dividing by 2, we would just multiply b times 1/2. So what's 1/3 times 1/2? 1/6. So that's b over 2. Then c must be, what goes right there, must be, I'm just going to square that. Well, what's 1/6 squared? 1 squared is 1. 6 squared is, so, right? No biggie. That one, all I'd have to do is just take half of 14.8 as decimal, what, 7.4? Square it, whatever that is, that's my answer. Okay, these kinds of questions, same thing, only this time you're going to write this out as a single, instead of just telling me what c is, they want you to write the perfect square. So this is even easier, really. What's going to be the perfect square there? X, what? What number am I adding to x? 9 over 2. That's what Moodle wants, right? Just write it as a perfect square. Same kind of thing there. Okay, what's it going to be? What's half of negative 1/3? Negative 1/6. That's my answer. Okay? Eventually, you're going to get to some problems that ask you to do this. Okay, all this is saying here is, you don't have to finish the problem. Just stop after you complete the square. So for example, all the ones that we did, we would have just stopped right, well, we would have stopped before we square rooted both sides. Our answer would have been x plus 3 halves squared equals 4. That's what Moodle, for those kinds of questions, Moodle would have just wanted that. You don't have to finish it. Okay? And then eventually you get to some problems where they're just going to tell you to do the whole thing. You know, actually solve the whole thing. Okay? Make sense? All right. So one other little piece that I got to tell you about. It's nothing new in terms of homework like on this topic, but just in general, something that I've seen that's been happening that I've fixed. Is this. I know a lot of people have been getting to the assignments by just going to quizzes, right? to see, and then clicking on with the next assignment they haven't done. That's good, except that you're missing an important part. You're missing the reading assignments that go with them. Notice for every section, like if I go into Unit 2, there's always going to be some reading, and then there's assignments that go with it, right? Well, I want you guys to do the reading. There's more to it than just being able to do the problems. I want you to actually, you got to do, they're very brief. It's not a big deal. Like if I pull up, what's an example? Like if we pull up completing the square. So if I pull up that reading, that first reading assignment is, look how short it is. Skip everything that's crossed out. That's it. I just want you to read through that and look at an example. Okay? So I'm going to give you, and this is a pretty good deal for you, I'm giving you free homework grades for doing that. So you'll notice here, like in 2.4, completing the square, the very first assignment you get is called A 2.4 required reading. So all you got to do on this is, actually it's going to be worth 25 in the grade book. What it'll look like. It's very simple. You go in here and you just say, assign yourself credit for reading the following things. And if you click on those are just links that take you right to the reading assignments. And once you've read them, you just give yourself credit. You know, if you do the reading, you look through the stuff you're supposed to, 100%. You just give yourself credit, and that's what's going to go in the grade book. If you don't do it all, you did some of it, you get half credit. If you do none, you get no credit, right? But that's pretty easy way to get some free homework credit in the grade book, right? So there it is. Does that make sense? Okay, go.